Michael, Rhett, Matt, and Kyle, and I'm just going to run through the project goals. The main goals for our project, we first wanted to research different designs and decide on what exactly we wanted to do. Our group decided to do a basic triangular truss system, and our goal was to build the strongest balsa wood bridge that met the requirements while keeping the cost low as well. So we were wanting to try to make a really light bridge. Strength to weight ratio, that gets back to the weight of the bridge that I spoke about. Our bridge actually was light, very light actually, and which was one of the primary reasons we chose to do a truss. And after the bridge had failed, we wanted to go back and understand why it failed and what we could have done differently to improve the design and the strength to weight ratio.
Design requirements, it was made completely out of balsa wood, and then we have a solid deck that creates a smooth transition from the supports to the actual bridge deck, just like a car. Minimum roadway width of 6 inches and half an inch diameter hole for the low beam, and a vertical clearance of 6 inches, so just like a real bridge, so a car can fit.
We designed our truss basically out of triangles, considered this the most stable system of members. For our beam, we had 2 beams on each side that were ½ inch, as well as the members in the truss. We used 1/4 inch wood for the joist, and then 1/8 inch for the deck. And this was constructed of a one-way slab, since we only had joists running one way. And we used liquid nail, which I thought was a very strong adhesive, since they use it in a lot of wood construction today. And, yeah.
The actual, that's just a picture of the construction, actually, how the process. We're actually gluing down the deck and have a weight on it to make sure it glues firmly. But we started off with our construction. We put the trusses together first. Once those were completely set up, put together, we connected them the bottom half with our bottom joist supports. And this is basically this is near the end. Once we had put the bridge deck right here at the bottom, we left that set up completely before we put our top bracing in. During the testing, we didn't have very much deflection at all when the load was being applied. Right before the last weight was applied, it was right at or right below a 1/10 of an inch deflection. So it was holding up. It wasn't deflating much until the joint failed in the center of the span.
All right. Our failure analysis. I've brought the bridge. Unfortunately, it's failed more since then. I had trouble transporting it. Basically, let me see. The first thing that broke, we had our joist or across here on our first beam. Connected to our first girder that was connected to our truss, and it broke first. And you can't see it in this picture. It'll show later in the slides. That when it was loaded, we had the last member that was loaded to the front half of the things called a small eccentricity, is called a moment to be actually applied to our bridge deck, which caused these joists to snap here. And once they snap, and the shear failure, it caused more of the weight to be shifted, or pretty much all the weight to be shifted to the other truss. Well, that truss was actually the one that's still undamaged. We had a glue failure occur here on this piece. It snapped from right. That was actually not connected at this point. It looks like it is in this picture. It's no longer connected, and once it completely failed, the girder coming across, had a tension failure caused by the moment. So that was pretty much how the bridge failed. Basically, once the joist originally broke, it just caused a chain reaction, and everything else just completely fell apart. After we know what we know now from the testing, we were looking at different ways that we could have improved it. When we designed our bridge, we designed it as to be able to transfer a weight all the way across it, not necessarily like we were supposed to. We did not make it a concentrated load. would have definitely changed that if we put it back. By doing that, we could have, put, instead of having evenly spaced out, joists, we would have probably had it more concentrated in this area. We would have also used thicker members for this joist because, that would prevent the failure. As far as, we'd also probably have run 2 more girders across here to also just to strengthen the bridge. And the glue did fail on that one member, but I feel that if we'd distributed the weight properly on the other part, it would have. I don't think that would have been a factor. And these are our results. Basically, we ended up getting our bridge weighed 294.9 grams, and our bridge actually failed under a weight of 55.3 kilograms, and that gave a strength to weight ratio of 187.5. So that's our results.
So how did you choose the triangle shape?
Just based off the stability. Everything we've done in class is, triangle's been the most stable structure, and we felt that would give us a more stable
So when you think of a supported beam, and if you put a cross-concentrated load in the center, you basically get a triangle-shaped moment diagram, right? So your bridge overall shape replicates the moment diagram, so it's basically a very efficient form to begin with.
I think it would have done a lot better if we would have ran 4 beams under it and then had a 2-way slab instead of just a 1-way. That would have made the load, would have made just the decking a lot stronger than it was, which that failed first, and when that failed,
Did you really need to put transverse beams towards the end, towards the sides of your bridge? You probably could have put them in the center, right? Just take them and then put them in the center, because they really don't do anything.
Under this loading condition, it wasn't needed.
For a moving load, that might have been more ideal.
Absolutely.
But for a center applied load, it was
we had a very
concentrate more
specific-
strength at the center where it was applied.
So would you change your glue next time?
I really feel that the failure is just because basically that joint was holding twice as much load as it should have been based off of the way it was designed. I'm not sure that the glue, none of the
I
other
really
joints
don't
failed.
think like it was because of the glue. If you look closely, like you can still see where the pieces were attached. The balsa wood actually just came apart. So
I think
I don't think it has. I really don't think the glue was necessarily why it failed. I just think the members weren't strong enough, and then it just.
I think putting 2 more beams or girders down the center span would have held a lot more weight.
Very good. Any other questions, group members? Classmates?
What kind of glue you guys use?
Liquid nail.
Liquid nail. Liquid nail.